Today we are going to see trigonometric functions. There are three primary trigonometric functions: sine, cosine and tangent. The reciprocals of these three functions are called secondary trigonometric functions. They are cosecant, secant and cotangent. Sine is defined as the ratio of opposite side to hypotenuse in a right angle triangle. The hypotenuse is a side opposite to the right angle. The period of sine is 2 pi radians, that is 360 degrees, and it has no asymptotes because it has zero value as a response. Sine 0 is 0. In the same way, cos also will have no asymptotes because it has zero response at 90 degrees. Cos 90 is 0. Now, cos is defined as the ratio of adjacent side to hypotenuse in a right angle triangle, where hypotenuse is a side opposite to 90 degrees. And tangent is defined as the ratio of sine by cos. So when cos is 0, tangent becomes infinity. Therefore, it will have an asymptote at that point. And the period for tan is pi radians, 180 degrees only. Cosecant will have an asymptote because it is the reciprocal of sine. When sine is 0, it will have an asymptote. Similarly, secant also will have an asymptote because when cos is 0, secant becomes infinity. At that point, you will have asymptote. Similarly, cotangent will have an asymptote because when tangent is 0, 1 by 0 is infinity. At that point, you will have asymptote. That means the response varies from minus infinity to plus infinity at those points. Now we will see visually all these graphs. Now here is the x-axis and y-axis. Minus 2 pi to 0 and 0 to 2 pi are shown here on either side of the y-axis. And 0 upwards up to infinity, 0 downwards up to minus infinity is shown here. We will see the values for sine function, cosine function, tan function and the reciprocals of these functions. Now we will see first sine function. As I told you, sine 0 is 0 and it goes to maximum value at pi by 2, 0 again at pi, and then at 3 pi by 2 minimum value minus 1 and then goes to 0 again. This pattern from 0 to 2 pi is repeated here minus 2 pi to 0. Therefore, the period is 2 pi radians, that is 360 degrees. Pi means 180 degrees. And the amplitude is plus 1 here, minus 1 on the other side, right? Plus 1 on the one side and minus 1 on the other side here. At pi by 2 it is plus 1, at 3 pi by 2 it is minus 1. And whenever sine is 1, the reciprocal also will be 1. Whenever it is minus 1, the reciprocal also will be minus 1. Therefore, you draw a cup at these maximum and minimum points, you will have the pattern for the reciprocal of sine, which is cosecant functions. I will draw the cosecant function here now. See here, the cosecant functions are cups with asymptotes. When sine is 0, it has got an asymptote. When sine is 3 pi by 2, when sine is pi, it has got an asymptote here. I will draw the asymptote and show you here. Yes, at sine pi, it has got an asymptote. Yeah. And similarly for cos function, the reciprocal will have cups just above the peak points for the cos functions. I will draw the cos functions now. Cos function is drawn here. Now you can see here the cup will be here. The cup is here on the red peak. Now it will be on this dark blue peak. I will draw this secant. See here, it is drawn at this point. I will remove the sine function and cosecant function. You can see here, it is just above the peak points. Right? When it is minus 1 and plus 1, you will have the cup. And the period is pi. Pi only. Minus pi by 2 to pi by 2. And for tan function, you can see here, tan function goes from pi by 2, minus pi by 2 to plus pi by 2. Again, when sine is 0, tan is 0. Right? Therefore, it will have the 0 value at x is equal to 0. And then all you need to do is draw a cup at 0 and then reverse the cup on one side. And that is a function here. This is the function here. For cot function, the reciprocal of this, that is cot functions, I will show you here. Yes, chord function you can see here. When tan is 0, chord will have asymptote. When cot is 0, tan will have asymptote, right? So when cot is 0, draw a vertical line, that is asymptote for this thing. Similarly, all you need to remember is either tan function or cot function. The rest you can find out yourself. Now I'll draw all the values. You can see here what is tan function, sine function and all. So at x is equal to 0, sine 0 is 0. Therefore, the red curve is the sine function. The dark blue curve is the cos function, because at pi by 2 it is 0. And then you know what is cosecant and secant. Cosecant is nothing but a cup drawn at the peak of sine, that is here, and then secant is nothing but the cups drawn at the peak of cosine function. This is here. And then tan function is 1. You draw a cup at x is equal to 0 and then reverse the cup on the left hand side, and that is the tan function here. Yeah, this blue color function. And you can have the asymptote for cot function when tan is 0, and this is the asymptote here. And then every pi you can draw it, and then you can draw the same pattern as tan pattern, the reversal of the tan pattern. This is the cot function here. You can see here the asymptote is at x is equal to 0. For tan function is this function, and then it will have an asymptote when cot is 0 here. The cot is 0 here. See here, the green function is the cot function. When that is 0, tan has got asymptote. I hope this is clear for all of you. You will be in a position to remember what is sine function, cos function, how to draw the reciprocal of this, just drawing a cup at the peak points when +1 and -1 are there. And then tan and cot functions are just reciprocals of each other. Tan will have 0 at x is equal to 0. And then draw a cup at x is equal to 0. And then reverse the cup at the left hand side. You got the tan. And the period is pi. I have used Maplesoft for explaining these trigonometric functions. I thank Maplesoft for this purpose. And I also thank Dr. Robert Loperts, from whom I have learned all this Maplesoft usage for explaining mathematical problems. Thank you very much.